Next, for the application of wireless power transmission, firstly, wireless power transmission can be used for wireless charging, for example, to charge smartphone, smartwatch and many electronic devices. Besides that, EV car, which is electric vehicles, also can be used wireless charging, which is transmitting power to charge the car. Smart home also use wireless power transmission to connect all the electronic devices. Lastly, the application of the wireless power transmission, it can be used in medical purpose, such as implant device to collect data.
Next, we'll be showing the steps to build the hardware of the project. These are the main components that will be used to build the wireless power transmission project. This project consists of transmitter and receiver part, which will be built based on the schematic circuit shown in the figure.
About how the wireless transmission, as shown in the demo before, is highly influenced by electromagnetic. In this study case, wireless power, or known as inductive power transfer, is established according to the Faraday's law of magnetic induction, or more so known to be related with mutual induction. The constructed system consists of a transmitter section and a receiver section built of coils of coil 1 and coil 2. The transmitter section with coil 1, which is connected to the power supply, generates a magnetic field and continuously changing its direction and strength, which means the magnetic field produced is also continuously changing. Faraday's law states that the EMF around a closed path is equal to the negative of the time rate of change of the magnetic flux enclosed by the path. With this, the coil 1 will oppose the change of its own current. What's happening is that the magnetic field generated by coil 1 is linked to the coil in the receiver section. By this, when the flux in coil 1 changes, coil 2 does the same, which results in EMF to be induced in the coil 2. Because the field is linked between the two coils, once the coils are separated, the EMF becomes weaker in the receiver section, as we can see in the demo where the LED lights up brighter when it moves closer to the transmitter section. This is where we derive the expression as shown here, where the EMF of coil 2 is dependent on the rate of change of current in coil 1. The mutual induction depends on the distance of the coil, but as well as the geometry, where the bigger the turns of the coil is, the bigger the effect to the rate of change of the current.
In the conclusion, wireless power transmission is a distribution of electrical energy from power source to an electrical load without need cables. Next is electromagnetic field, which is it will transmit energy from transmitter to receiver. And lastly is the energy transmission efficiency, which is determined from elements of coupling and also the quality factor of the coils. That's all from our group. Thank you.